Generative AI is a fascinating field of artificial intelligence. It focuses on creating new content. Imagine AI writing a poem or composing music. That's what generative AI can do. It learns from existing data like text and images. Then it uses this knowledge to generate similar but original content. Generative AI has many applications. It can write stories, create artwork, and even generate code. This technology is rapidly changing how we create and consume content. From writing assistance to artistic inspiration, generative AI is opening up new possibilities in various fields. One of the key elements driving this technology is the use of neural networks. These networks mimic the human brain structure and function. By processing information through layers of interconnected nodes, neural networks can learn patterns and generate creative outputs. This ability to learn and adapt is what makes generative AI so powerful and versatile. Neural networks are the backbone of generative AI. They are complex structures inspired by the human brain. These networks consist of interconnected nodes or neurons organized in layers. Each connection between these neurons has a weight associated with it. This weight determines the strength of the connection. During training, a neural network learns by adjusting these weights. The goal is to find the optimal set of weights that allows the network to perform a specific task accurately. For example, in image recognition, the network learns to identify patterns in images by adjusting the weights of its connections based on the images it is trained on. The process of training a neural network involves feeding it large amounts of data. As the network processes this data, it adjusts its weights to minimize errors and improve its accuracy. This iterative process allows the network to learn complex patterns and relationships within the data, enabling it to generate new content that reflects those patterns. Machine learning, or ML, is a crucial aspect of AI. It allows systems to learn from data without explicit programming. Essentially, instead of being explicitly told what to do, ML algorithms learn to identify patterns and make predictions based on the data they are trained on. This ability to learn from data is what makes ML so powerful for tasks like image recognition, natural language processing, and of course, generative AI. Deep learning, or DL, takes ML a step further. It uses artificial neural networks with multiple layers. These deep neural networks are capable of learning more complex patterns and representations than traditional ML algorithms. This makes DL particularly well suited for tasks involving large datasets and complex patterns, such as image generation and natural language processing. In the context of generative AI, DL is used to train models that can create new content. For example, a DL model trained on a dataset of images can learn to generate new similar images. Similarly, a DL model trained on a dataset of text can learn to generate new text such as poems, code, or even scripts. One of the most significant advancements in generative AI, particularly in natural language processing, is the development of transformer models. Unlike traditional models that process text sequentially, transformers can process all words in a sentence simultaneously, allowing them to understand context and relationships between words more effectively. This ability to understand context is crucial for generating coherent and grammatically correct text. A key innovation in transformer models is the use of attention. Attention allows the model to focus on specific parts of the input text that are most relevant to the task at hand. For example, when translating a sentence, the model might pay more attention to the words immediately surrounding the word being translated to ensure the translation is accurate and contextually appropriate. This attention mechanism has revolutionized natural language processing tasks, leading to significant improvements in machine translation, text summarization, and question answering. Moreover, transformer models have paved the way for the development of advanced language models like GPT-3 and its successors, which can generate remarkably human-like text.